Okay, let's try this. Konnichiwa, keiyo wa kite kudasari arigatou gozaimasu. So you can see my email here. Just send me something, and I'll send a lot of links because you will see that it's a really long presentation, and maybe you will miss something. So I'm the second time in Japan, and I can say that it's awesome. Also, I learned more things in Japan on my second time, and I get answers for really important questions for me. The first question is ramen still awesome? I can say yes, it's awesome. The second important question, is Java more popular than Ruby? I can say yes. The next question, it's a really important question, and I got answer today. Is Ruby still dying? Of course. And the last question, it's is RubyKaigi still awesome? And I can say yes, of course, it's still awesome. Thank you so much. I'm super happy to see you all here. And I'm super happy to be here again. My name is Anton, and you can find my contacts info here. And I am from Russia. It's near with Japan. Just 10 hours on flight. And you need to know about me 2 things. I really love stickers. I have a new laptop, that's why it's empty now, but maybe in future. And the second thing, it's I really love open source and ideas from open source. But anyway, some little announcement, please danger, it's a really big presentation. And that's why I repeat it again. Send me anything on this email, and I'll answer you with a lot of links from this presentation and this presentation too. So, and today we'll talk about architecture. I'm not a senior architecture, but you can trust me. And the general question why I create this talk. This talk I create just to unify architecture ideas from Hanami projects, because I'm writing a lot of Hanami projects, and I try to understand what's the best way to managing with dependencies, with business logic, and etc., etc. And also I want to get some feedback from you. And if you want to say me something, please find me tomorrow, today, or on last day of the conference. And we will start talking about problems. And who loves problems? Oh, really? Okay. In my practice, each application, each project, each company usually have 3 different problems in technical side. It's management problems, like deadlines and etc., etc. It's performance problem. It's something like when you have n+1 SQL queries, and maintenance problems. And today we will talk only about maintenance problems. And let's talk about some interesting thing which you can find in internet. It's a clean code, good architecture, maintainable project, and etc., etc. And someone can explain me what good architecture is mean. So I think it's a basic view, because usually it's really complicated to explain what clean or good or maybe maintainable is mean. And that's why let's try to answer on simple question, what do we really want in our system. And of course we want to add new features. And usually for adding new features you need some rules. And usually it's isolation, sequence logic, and programs without global state. And of course we want to delete or maybe refactor some features. And for this we need to isolate some parts of our project, because we want to easily maintain only one part instead of 10,000 lines of code. And of course we need to test coverage.
And if we will conclusion all the stuff, we will understand that from maintainable system we need to in maintainable system we want to see isolation, sequential logic. This system should be without global state, and also it's test coverage. And unfortunately, we live in the real world, and in the real world we have something like this. It's a real Rails action. If you want, I can show all this code. It's more than 2,000 lines of code. And how we can improve this situation. And first thing which we need to know is abstractions, because abstractions everywhere. And we will start our talk from actions. And I'll repeat my previous slide again. And in some internet articles or books or maybe blog posts, you can find that MVC pattern is super clear, it's super easy for maintain and building. And I agree, because you write some view controller, and after that you create MVC pattern. And some solutions for this problem. It's a functional objects, or also it's called callable objects. It can be anything. It can be services, interactors, dry transactions, dry monads, or with do notation operations, and etc. etc. It's a small question. Who used dry transactions, for example? Wow, a lot. And what is it in general? In general, it's just object. You create an object without any state. After that, you call some method. Usually, it's a method call with some parameters, and got a result object and work with this result object, and that's all. No, it's no mutable state, no something, and also it provides isolation for our projects. Just look on simple example from hanami action. You can see that we get a result, and after that we work with this result without any problem. Also, callable objects provide some sequenceful logic. Just look on dry transaction. Example is real dry transaction from my project. And usually you can see that we have 3 different steps. It's extract some data, validate this data, and create something. Also, you can use the notation. It looks similar. You can extract, validate, and create. Or you can forget about all this stuff and just call create, extract, validate, and create. Also, callable objects doesn't have a global state. In global state, I mean this thing. Every time you create a new instance, and also you call method not mutate any data in your object. And the most interesting idea of this callable object, it's really easy for testing. But for easily testing, you need to rewrite this action, create a constructor for your action, put a functional object into this, and use a functional object in your call method. And it's called dependency injection. And who love dependency injection in Ruby? A lot. So why it's important? It's important because we can inject different functional objects into your hanami action or any different objects. And it means that in our test, we can create a simple unit test, and it will look like this. You just create a new action object with new instance of your dependency, and you can switch this dependency from successful dependency or maybe a failed dependency, and that's all. Also, you can use lambdas and procs. It's allowed too because they have a call method. And the last thing, it's some objects can call other objects, and in my brain, it's something like we have action, for example, from hanami action. We have interactors. It's something public, which can be called from actions on other places of your code. And these public objects can call private objects from libraries. But of course, we have some problems with this pattern, with these ideas. And first of all, we have so many objects, and it's really hard to manage all the stuff. Also, we use some namespaces and scopes, and that's why we have really long names for objects. And for example, the last one, it's orders, current, coupon, operations, apply. It's a real namespace from my job. And it's really hard to every time read something like this. And the last problem is every time when you call functional object.new, you will initialize a new object, a new instance of this object, and it can be bad for performance. And we can solve all this problem by containers. The next abstraction which we will talk about is containers, and I'll talk about dry containers. Someone used it before? Okay, it's cool. And I have a funny picture about it. So what's the idea? Idea is super simple. You have an instance of container, and after that you can register some dependency with specific key. And after that, you can call this dependency by this key and get this dependency, and that's all. And in our example with hanami action, it's look like this. We have a container, call some key, get instance of create user, and for this instance, we call method call with some parameters. Some pros, we control it our global state, because we don't create a lot of constant in our projects like Redis constant and etc. etc. Also, we can memorizing instances for better performance, and it's easily to testing because you create a mocks for container dependency, and we can use it better. And for this, we will go to next abstraction. It's dry after inject. I have a funny picture again. And why we need to use it? It's a dependency injection on steroids for dry containers, and not only for dry containers. And for using it, you need to just add only one line. It's look like this. What does it mean? You create a new instance of your container, which you will use in your classes, like this. And you can see that this line just adds some, oh, I'm sorry, it's layout missing. This line just create a constructor method, initialize, create a getter for your dependency, and after that you can call your dependency as a usual getter from Ruby, and that's all. And of course you can use some dependency injection features and etc. etc. And let's talk about models. I told that MVC as a pattern is super simple. Just create a view and controller, and after that add models, and that's all. But what can we do with it? First of all, we need to decide that models, we need to decide that all logic should be in services objects rather than models. And also, we need to decide that validation in model is a really bad practice. And our models, they should just save and load some data, and that's all. In Rails community, I know that query objects is a really popular pattern. Who uses query objects? Yeah, it's more than containers. In Hanami world, we have a repository. If you open a Hanami guide about repository, you'll find this description. And also, for some complicated logic, when you need to create and store or save really complicated entities and update some keys or something like this, you can use change sets or common pattern, but it's wrong. Just change sets. It can drop some callbacks,
and create some sequence for logic. And for example, just check this code. It's some class which inject user repository, and after that, instead of merging some created on information into your payload, you can just create a change set which will do it without any problem. And after that, you'll create a change set and use this change set for creating entity in your database. The next thing is application. It's my favorite part of this talk because on previous job I work in small company. We use Rails application with some models and services. And after some time, I found that we have two different Rails applications with models and services, and unfortunately, they had a similar model and services. We use one database, one migration, and for update one second application, you need to update the first application, create a migration, call this migration, and after that, you can update models in the second application. After some time, we create other application, and unfortunately, it was with shared model too. And all this application use a model and database from the first application, but usually it was something like administrate application, web application, and an API or something like this. And from some time, I saw a ticket that we need to create one more application, and unfortunately, I leave from this job. And if you look on typical Hanami application, you'll see that usually it's a project. In this project, you have some shared business logic, and this logic shared between apps. And it can change your mindset, because it was from my side. And what does it mean? If you remember previous slide with actions, interactors, and libraries, you can easily change it to applications which call interactors from your business logic, which call some libraries, and et cetera, et cetera. And it's super easily to use because you can create some web application, administration application, API, and mobile. Use different applications, but same business logic with same models and same data store. In Hanami, you can start only one application. It's super important when you want to schedule your project into different pods in Kubernetes, for example. But still, we have some problems. It's a real case. Sometimes it's really hard to not forget about other applications. From my current job, we had a problem when one developer update mobile API and forgot to update administration application and broke this application. It's really hard to remember all the stuff, but you need to do it. And sometimes you need to use some similar but different logic in different places. And we need to go deeper. And little warning, it's a really advanced level. You can build any application with all the stuff which was before, but with next stuff, you can improve your quality and maintainability of the project. And the first thing is dry system. Dry system. Sorry, I didn't find some funny pictures for this case. And what is it? It's just dependency management system. It can do only two things. The first thing is after register dependency into container. It's like a Rails after register, but you register all the stuff into container by a specific key. And some example, so you can see that you need to after register all dependency from library folder. After that, you create a logger in the library folder, and after that, you get this dependency in your application. I'm sorry for the slide. So in the other side, it's my favorite side from dry system. It's dependency booting. What does it mean? you can create a specific register block. And in this block, you can say that, OK, in initialize of application, you can create something, some instance, check some connections to database, and et cetera, et cetera. On start, check connections again. And when this application will close or stop, you can close all connection, and that's all. And you can do it for any dependencies in your systems. And all these dependencies will go into one big container. In this case, it's application container. So the next thing is domains. Who love DDD? Oh. I know that in Polish, I know that Polish developers love DDD. But if you want to understand what is it and why domain-driven design is really cool, you can read this book. It's a really good book, but it's so big, and you can find a quick, it's smallest book, but when I read this book as the first time, my face was like this. And the general idea of all this stuff is you can create a separate domains for different business values. What does it mean? You can create one big domain for orders, for example, if you work on some shop application. You can create one domain for orders and second domain for users, and use the different domains. And the general rule is each domain in your project is related from other domains. And we have some pros. It's easy to create separated services. Just replace your domain, create some transport level between services, and that's all. And also, domains are really good. Domains are really nice to see in containers, because you can call key like domain name some services dot service name. But some cons, it's really hard to start, and if you have a small proof of concept application, it's somewhat overcomplicated. And also, it's created so much files, and et cetera, and why we need all this stuff, and that's all. So, and if you look into similar Hanami project, you will see that we have some applications, and some domains and some core stuff like repositories, for example, or maybe some network clients, and et cetera, et cetera. And you can see that each application can call different domains. And for example, admin application can call all these domains, API application called only this, and web application call only these two. And if you look on this image, you'll see that HTTP is a really small part of your system, because all this application in Hanami, it's just HTTP applications. But in real world, in real applications, instead of HTTP, we have WebSockets, REC, background processing, ETL stuff, which we talked before my talk. And all this stuff use business logic, this logic. And a system consists of different events. It means that, for example, in this case, for example, when you create a user, you create events and user was created. When you create an order, you create events that order was created. When you check out order, you can create events that order completed. And the last part of my talk is event sourcing. Who know what is it? Oh, it's nice. So the general idea of event sourcing, it's, I'm sorry, wrong slide. So you can find a really full description what is it on this website. It's microservice architecture. It's a good explanation what is it. And in a few words, event sourcing is something like you have applications, for example, some different applications. And all these applications create events. They don't store some data in a database. They don't store some data in anywhere. They just create event, and that's all. I'm sorry, I have a problem with clicker. They create some events, like user created with all information about user, order created with all information about order and etc. And those applications stores these events into event log, and that's all. And also we have different type of application, usually it's consumers. They just take events from event log and process it. They can do anything and what you want. And the general idea of this is you can use anything, any languages, any technologies here. For example, it can be Rails application, which will store some events into your event log. And after that, you can take some Elixir, for example, or maybe Crystal, if you want. But the general idea of this way is if you want to show to user history of his orders, you need to calculate all events for specific user, for specific user, for specific event, and calculate all the state every time. And in this case, we can create a new abstraction which call it SQRS. The general idea of this abstraction was described by Martin Flower. And imagine we have event store system, some broadcast and consumers, and event log. And for example, we have some different persistent layers like SQL, Elasticsearch, NoSQL database. And we want to say that, hey, if we send some event into consumer, we want to cache this current state of your system in some cache persistent layer like SQL. And when our main application say, oh, okay, I need to know all information about orders from user, they'll go not to event store, they'll go to cache like SQL, get some simple request, simple select request, get all information and display all this information into application. And if you talk about Hanami, we can start one application of Hanami. For example, it can be a web application of Hanami for sending events into event log. Start Hanami without any application for consume all these events, and use SQL or Hanami model or anything else for working with current state of your system. And some pros of this approach, it's you can read all the stuff, and also some cons. It's in the general cons, it's not a silver bullet, and it's not a popular in Ruby, as you can see. Also, it's really complicated. You need to change your mindset and etc., and you need to use a good tools. And how to start use it? Few talk ago, we talked about Kafka. You can use it if you want to use Kafka as event store. Also, you can look into Rails event store from ArcC guys. Also, I found this library, but I never use it, and I think I need to play it more. And also, we have Hanami events, but usually now it's just proof of concept, and we decided that it's just pub/sub system for working with events in your system. But it's easily to add your adapter, for example, SQL adapter or maybe Kafka adapter or what you want, and use it without anything. And it's not about Hanami and Rails or Rails and Hanami. For example, in my company, it's called Hippo. We use full stack dry application with ROM without any Rails applications, with few Hanami applications. And here we use event sourcing with all the stuff. And some conclusions. The first conclusion, it's isolated. Please isolate your business logic. Isolate what you want and what you can. Also, don't use anything anything having no idea why do you need it. Because it's important, because you need to understand why you need it. And only after that, you can start to use it. And the last thing is maintenance is really important for large systems and for complicated systems. Some ideas you can find on this link. Real example with hanami, with dry system, with do notation from dry monads, you can find on this link. Also, on this link, you can find a gist with a lot of links. Also, I want to say again, please send me something, and I'll send all these links into you by email. And that's all. Thank you. Let's go drink coffee. Okay, thank you. Oh, I see a question. Nice. You're my hero.
Okay. Hello. I want to ask about the architecture, about the models and repositories. Because I'm using Rails and I want to compare Rails and Hanami. In Rails, there is active record ORM, yeah. And Hanami don't have it. Then Hanami using repositories and models. What I want to ask is why do you use repository and models, and maybe about positive and negative about that.
So if I understand right, why we need to use repositories in Rails and pros and cons, yeah?
Yes.
Why we need to do it? In my opinion, Rails have a lot of logic in models. It's validations, it's callbacks, it's logic to get and store data in persistence layer, it's logic to work with entities, and etc., etc. And in my thought, in my brain, I think it will be better to separate some logic to other places, because it's really hard to maintain a really long Rails models, because first part of Rails model is usually its class methods. After you have instance methods, and after 5, 10 instance methods, you can find some class methods, and etc., etc., etc. And in this case, it's much better to create other place where you can put all this persistence layer stuff and just call it, instead of try to find some persistence class or persistence method in your model. Some cons and pros. So advantages of this way, it's easily because you separate some logic. It's easily to find something. It's easily to test because you can easily mock, for example, dependencies. You can create a class, put model into constructor of this class, and use it in your application. And if you put a double object in testing, you'll get an easily way to test all the stuff. Disadvantages of this way, it's you need to create one more abstraction. You need to find a place where you need to put all the stuff, because Rails application folder is really big, and if you put all the stuff into Rails application folder, sometimes you'll lose everything. Also, it's really hard to understand to other developers to explain why we need to do it, and it's not a Rails way. And I think it's the biggest disadvantage of this way.
Okay, thank you.
You're welcome. Okay, thank you.